Now it's my pleasure to welcome on stage Thomas Müller-Kirschbaum. So he has a long expertise at Henkel. We already heard a presentation from Henkel today. And now he's an expert from the Circular Valley and giving today a speech about the expenses and how expensive it is to think and work in circles. So Thomas, the stage is yours. Thank you.
Is this micro open now? Yeah. So good afternoon also from my side. Thank you very much for the kind introduction. We have only short time, and I'm from the fast-moving consumer good industry, so I speak a little bit faster than average. But afterwards, if you would like to, you can have my slides or you can study it in more detail. So the question is for me always, if we talk about these loop, so we want to have a closed loop, and very often there are economic limits. If there are no economic limits, it would run anyway. But obviously, as we are not at 100% closed loops, there is an economic limit. That's a question for me, how expensive those things are. And that is the idea of the presentation. Here you see just what the Circular Valley is doing. So we are working on 3 pillars. One is we accelerate startups in their development for circular economy. With our partners, we develop policy recommendations, and we open the topic of circular economy to the public, for example, as we are here at the Circular Valley Convention. So back to the presentation, what you can expect is a backcasting exercise. So we go into the year 2035 and think what we have to do now to be at 2035 in a closed loop plastic packaging cycle. So we look at the economy, we look at the technology, and we look at smart regulation. So the overarching principle is that we have a closed carbon cycle, means no fossil carbon. So carbon from the atmosphere or carbon from the biosphere can go in, but no carbon from the ground, so the geosphere. And we want to lower the greenhouse gas emissions. It is based on work that started in the year 2022 with the Circular Economy Initiative Germany, but we developed it further. So, the agenda. First, we talk about the plastic gap that we face in the year 2020, recycled plastic gap, not plastic gap. And then the solution could be that we try to close the loop, that we do not have any issues with recyclates, because we have at the end 100% recyclates, ideal form. So and then the question is it technology-wise possible what we have to do? There we have an assumption, and then we translate that into the conditions for economy, for technology, and also for regulation. So, and at the end, I have a call for action. What is homework for all stakeholders? And that is a cross-stakeholder homework, as we have to work together, to partner together. We heard that several times today, and across industries. So, if we have a look at the PPWR, and what industry is doing, we see that there is a lot moving on. Even if you cannot read all the details, you know that the PPWR says that in 2030, in 2040, there should be a certain kind of recyclates in our packaging products, depending on the material and the kind of packaging. And you see on the other hand, and Henkel is an example that I know very well because I collaborated with those colleagues who started this commitment in the year 2018, that says we have at the end, we want to achieve that 30% of the plastic material that we use for packaging is in the year 2025, so end of this year, 30% is from recyclates. And you heard from Ulrike Sapiro that Henkel achieved last year, published yesterday the figures, they achieved already 25%. So it's very expectable that they will make these targets. But it goes even beyond. What it says is, the message is, we need a lot more recyclate than today. That can be used for high quality packaging. And on the other hand, if you see a recent study of the plastics manufacturers, then you see these 3 bars, and they say in the year 2030, we need round about 3 million tons of mechanical recyclate, but if in a business as usual scenario, we have only around about 2.1 million, and even in an advanced scenario, with a little bit of chemical recyclate, we end up at 2.7. So it means there is a gap. That's my message. And then the starting point of the idea is, let's assume we have already a closed circle, and the question is this closed circle economically viable? And that's the question. So we are back on, we want to avoid this recyclate gap, and we are open for all technologies, and we make a scenario for 2035. So we have, if you leave the room, you have 10 years time to make it happen. And the principle is, as you can read there, is a closed carbon loop, means if carbon comes in only from the biosphere, we have no additional fossil carbon, we have low greenhouse gas emissions, and all plastic recycling technologies participate and contribute. And we have, of course, material losses, but they are refilled by renewable plastics. What is at the time being, it's bioplastic, or plastic from bio-based materials. And the scenario in our example, to keep it simple, you can even expand it, is for PET, HDPE, and polypropylene. So, and the target is find conditions which make it happen that it works. So, first, technology-wise, why do we need all technologies? If you look at this slide, you can even talk about this slide 20 minutes, so we do it in 30 seconds. We start at number 1. You start with 10 units of plastic that you use for packaging, and you recycle classical way in mechanical recycling, and you know there is a trickle down in quality, so you end up at the bottom at number 2. With a little bit material loss, but with a quality that is lower. And to go up to the quality again with the elevator, you need chemical recycling or solvent-based recycling methodologies. You have even additional material losses. And if you want to have at the end, number 4, again, 10 units, you need to add up, you fill the material losses by plastic that comes from biological sources at the time being. So that is for the technology that we need all these 3 technologies. Here you see what we have to deal with economic, with technological and regulatory parameters. Is like a balance. It has to be in the right balance, otherwise the model would not work and the economics would not work. And we discussed this later. We come now to the assumptions for the year 2035, 10 years from now, please have in mind. So we say there is a flat development, whatever you can expect, because we do some reduce, we do some refuse even in plastic packaging. So, and that we even are on a flattish level with 3 million tons in the 3 material sorts: PET, polypropylene, and HDPE. But we have €800 for the extended producer responsibility fee, what is maybe lower today. Nobody knows exactly the figures, but we assume 800 in that time, and you get an eco-modulation of 30% if you use recyclates from chemical recycling, renewable plastic, and even mechanical recycling, of course, what today. So there's a huge, significant eco-modulation. And another assumption is the on-cost. So mechanical recyclate costs 30% more than virgin, chemical and bio-based even 100% more. So that's our assumption in the year 2035. The CO2 fee in the year 200 might be high today, but we are 10 years ahead. It's €200 per ton. And we have then a CO2 footprint that we also assume that is 20% for mechanical recyclate, 30% for chemical recyclate and bio-based PET. PET is easier to depolymerize, and for chemical recycling and also for bio-based material from PP and PE, we have even a higher footprint, which is 50% of virgin. So, and if we do then the calculation, we have 2 assumptions: business as usual. that says we would be in the year 2035 at 70% virgin and 30% mechanical recyclate. And the fully circular there is no virgin material at all, but we have 80% mechanical recyclate, 15% chemical recyclate, including solvent-based, and 5% bio-based to fill the gaps. So, and if you do the mathematics behind, it's not difficult. Then you end up with an on-cost in both scenarios, and the on-cost is around 1.1 billion euro. So that's a lot. We will come to that amount later, but you see there is a slight economic advantage for the fully circular loop, and in addition, you have much lower greenhouse gas emissions that are 70% lower than business as usual. That's a lot. So, and just the question is, can we afford it? Yes, we can, because it's 4 per 100-gram bottle of PE. If you divide this 1.05 billion euro by 3 million tons, then you end up with around about 350 euro per ton, what is at the end less than 4 cents per kilogram, and less than 4 cents per 100 gram. And this is a 100-gram bottle here, for example, for 2 liters of detergent. So you see, it's feasible. That I want to show. And the ecological results are clearly showing that the direction of it's possible economically. It needs some investments, and it needs investments, for example, in much more capacities in mechanical recyclates, but also in chemical recyclates, including solvent-based, but also in renewable plastics coming from bio-based. And with that, my last slide. That is the homework for all stakeholders. You see here several lines, and at the end there's always the stakeholder who is, let's say, in the focus. To do these changes, we need a harmonized EPR system all over Europe, at least, and with a significant EQ modulation that we do not have today, and the use of recycled and bio-based plastics. And the ETS-like scheme for the CO2 fee, that is a topic of regulation in the government. Then we need solvent-based and chemical recycling capacities, technologies developed, that is a topic of chemical industry, governments, but also the academia, means research. The same for mechanical recyclate. So I'm talking here very strongly on increasing capacities for mechanical recycling. We need much better qualities for packaging, just to take up these materials, and also ISO standardization and so on. So this is also a job for the recycling industry and governments and academia. So, and at the end, we have to have give the clear signal to retail and all of us that will cost a little bit more. What I said, 4 cents per plastic bottle. That is, I think, affordable. We talk about a timeline of 10 years. That is 0.4 cents per year. That I think everybody can afford, and in particular if we prepare ourselves. Thank you very much, and I hope I have started a little bit of discussion and about this vision. Thank you.